6. Divide each term by 4. And I have y is less than negative 1/2 x plus 3/2. So my slope is negative 1 over 2 or 1 over negative 2. I can put the negative in the numerator or the denominator or out front, and the three fractions are equivalent. And then my y-intercept is 0, 3/2. So if I move to that point, 0 in the x direction, 2/2, 3/2, so halfway in between 1 and 2. And then I need to do a rise of a negative 1, so halfway there, and a run of 2, so 1, 2. So it'll be halfway between the 1 and the 0 and the 1. And then my other point, starting back at the original, 0, 3/2, a rise of positive 1, so halfway between there, and then a run of negative 2. And this one needed to be a dashed line. All the way to the sides of your graph. And then I can use 0, 0 as my test point. Go back to the original, so it'll be 2 times 0 plus 4 times 0. Is that less than 6? And that both of those terms come to 0. So I have 0 is less than 6. That's a true statement, so I know this will go towards where it will include the 0, 0 coordinate. My second line is y is less than or equal negative 4. Think about y is 4, negative 4. So 0, negative 1, 2, 3, 4, 2, negative 4, and 4, negative 4. And of course it's a horizontal line, and I have a solid horizontal line, so let's put that one in. Then I need to check, and 0, 0 is going to work just fine for my test point again. So put in 0 for the y. Is it less than or equal negative 4? And that's a false statement, so I do need to go below so that I don't include 0, 0. And I needed to use the intersection. There's one keyword, and that's my other keyword. So that's the case where we have to agree on what we're having for dinner, so we only take what we both want. And if you look at the graph, these are going down, but this is only for the top line, and this will be for both of the lines in this region here. Now if I extended this one out a little bit further, that might help just a tad, because the part that's this part here is not going to be in common, but all this part down, down, down below, they both agree on it. This one wants to go that way, and this one wants to go that way. Okay? Domain and range then. For my domain going in the x direction, it looks like there will always be a value for y, so negative infinity to positive infinity. And the range looking in the y direction, we are good, lots of values all the way up to a negative 4. So negative infinity to negative 4. And is the negative 4 included? It is, because it's a solid line, so there's my range. Okay, one more for you to try. First thing I see is that I have a dashed line here and a solid line here. So for my dashed line, I'll subtract 2x from both sides so I can graph it, and I'll have negative y is less than negative 2x plus 6. And I need to divide by negative 1. And remember, if I divide or multiply both sides of an inequality by a negative, I have to flip the inequality. So I end up with y is greater than, it turns this to a positive 2x and a minus 6. So I have y is greater than 2x minus 6. So my slope is 2, and think about it as being over 1. Or I can always think of negative 2 over negative 1, just like I had up here when I was trying to solve for the y. It's equivalent to the 2 over 1. And then my y-intercept, of course, 0, negative 6. The negative 6 is the intercept. And if I go to 0, 1, 2, 3, 4, 5, 6 in the negative direction, my point is here. And then I need 2 over 1, so a rise of 2, a run of 1, or back at my original point, a rise of negative 2, a run of negative 1. And remember, this was a dashed line. So come back to graph that. And a test point of 0, 0 looks like it'll work fine. The original problem gives me 2 times 0 minus 0 should be less than 6. So 0 minus 0 is less than 6, which is a true statement. So I know this point is included. So I'll put a little arrow showing which way to go at both ends of my line. And then for my second inequality, it's already in y equals mx plus b form, so I just need to pull out my slope is a negative 2. Think about it as over 1. And it's the same thing as 2 over negative 1. My y-intercept is 0, comma, positive 4. So at 0, 1, 2, 3, 4, I need a point. And then I will use the rise of negative 2 and a run of a positive 1. Back to my original point, a rise of 2 and a run of negative 1. And this line needed to be solid. So let's put our solid line in there. And a point to test of 0, 0 looks like it'll work just great. So plug that in. 0 is greater than or equal negative 2 times 0 plus 4. And 0 for this term, so I have 0 is greater than or equal 4, which is a false statement. So I cannot include the 0, 0, so I have to go the other direction. And then come back. I was looking for the union with an or. So union, remember, is all the furniture coming together, all the furniture from him, all the furniture for her, so everything together. So all the points that are in the graph for any of the quadrants. So the part that is not included is this small little piece right here. Domain, in the x direction, it looks like there will always be a value corresponding for any x. So negative infinity to positive infinity. Range, coming down for the y direction, start at the negative infinity end and go move to the positive infinity end. We'll always have a value somewhere. So negative infinity to positive infinity for both of those. Here's your last one to try, and it's a little bit challenging. Alright, so we have to remember about the absolute values. We have this absolute value is greater than y, so x minus 5 is greater than y. Think of it as having an equal sign, but remember when we go to graph it should be dashed, and this one should be solid. So if I make an xy table, I really want to know where is this going to evaluate to be 0, and I can see if I put in a 5 for x, then I will put a 5 here, so it'll be 5 minus 5 or 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0 So if I'm on the equals part, my y would be